Greetings and welcome back to the Building HVAC Science Podcast, where it's our goal here to create better, more knowledgeable HVAC and building performance technicians by helping these two professions better understand each other with the ultimate goal, making customers happy in the homes they live in and the buildings they work in. I've noticed a need for scientifically rooted information in my 30-year career on how to technically do a job correctly. And that's really what I focused my career on, is providing technology to HVAC and building science. I'm a person who tries to understand things and communicate what I understand, but always seek the truth to find out more about what is going on, why it's happening, and look for the scientific rooting and grounding in these topics. In this podcast, I welcome Julian Stamatakis. He's co-founder of Attune, a company formerly called Senseware. Julian is a scientist. He's worked on sensors and technology his whole career. He began by collecting energy data and expanded into various sensors to monitor air quality conditions. Now, this is primarily for commercial, not consumer, not residential type situations. He talks about the evolution of sensor technology and how they're using machine learning and artificial intelligence to help building engineers, building managers make decisions about how to control the air quality in the space. And this one also includes schoolrooms. And systems are installed in thousands of classrooms and offices and commercial facilities. So let's listen in as Julian delves into the use of using data analysis for good decision-making in building management. Good morning, Julian.
Hey, Ben. Good morning.
As we started off the conversation here, you talked about your expertise is in sensors to monitor the built environment, especially IAQ, energy, and occupancy. How did you get to this point? What studies, what work, what experience led you to this company?
That's a very good question. It's been a long journey. I initially started in networks of sensors when I was doing my master and PhD in Belgium. And the idea was to actually collect accelerometer data from people with Parkinson's disease. So develop all the hardware to collect the data and then do data analytics to try to better predict the disease. Because one of the challenges is that with the disease, you have tremors and difficulties to perform some movements. And it's not always easy to detect by naked eye, especially in the early onset of the disease. And so we thought using accelerometers, we would be able to detect that better. So I did all that. And then one of the conclusions of my PhD was that accelerometers were not enough. We needed other types of sensor, maybe gyroscope. And at that time, they didn't have like all those fancy accelerometer, gyroscope, combined units and whatnot. So that was one of the conclusions. And it's towards the end of my PhD that I met my co-founder, and he was doing also a PhD in biomedical engineering. And so we thought, it would be cool to create a system to collect data from multiple types of sensor in a medical space for whatever disease detection. And so that's how we started. But in the medical space, there's so much red tape. It was impossible to get funding every time we're submitting application to the NIH and stuff. It's like, big companies are working on this. I'm like, okay, whatever. So we never give up. So we took that idea, went to some startup events and just say, we have a system to collect data. And then a lot of people in the build space told us, well, actually, we need to collect data from buildings and we don't have good ways to do it. And so, okay, that sounds interesting. And so that's how we started. I don't know if you know them. The very first company we worked with was a company called Aquicore that's famous in this area 10 years ago. We started by collecting energy data from energy meters. So we basically have a plug and play wireless system to easily collect data from those meters. And that's how we started. And then after that, because we had the ability to add other sensor, we just ask customers, okay, now you have energy, what else do you want? And so we continue with energy and stuff. Water, IQ. Yeah.
Is the use case mostly, you say built environment, that sounds like a commercial or real estate or a facility type of thing versus the home?
Correct. Yeah, that's one of the things very early on. We decided to stick in our lane and just work with commercial customers. I don't know. We thought that residential was, especially consumer, was just so different. And we decided there's a lot more competition there. Seems like in the commercial space, there's not a lot of competition for some reason. And so, yeah, we decided to stick to that market. And still to this date, we're not doing any consumer or residential applications.
I'll say from my perspective, the commercial space tends to be detached data, capital investment, productivity oriented, where the consumer space tends to be more emotional, health oriented. And those are very fuzzy topics to provide information on.
Yeah, definitely. And also from my perspective, because I'm on the tech side, is the technologies that you need are very, very different. On a more consumer side of things, it needs to be low cost, probably Wi-Fi based systems. And then that the opposite in the commercial space where Wi-Fi is not great and you need very robust sensor that will last for a very long time and provide very accurate data.
Tell me about now what type of sensors you have, the type of applications, how they're connected.
Sure. So on the air quality side, how we started was with the wildfires. I don't know, I can't remember now, 6, 7 years ago when started to have a lot of wildfires in California, or at least customers told us about it. And so we had customers who were using us for other type of data, and they said, okay, can we start collecting particulate matter data? And so that was really the very first use case we had there. And it was basically looking at how much of that smoke and how much of those particulates were making their way inside the building to make sure that the employees and the people working in the building were not at risk, and looking at the efficiency of their filtration systems and stuff like that. Then the second use case we got shortly after that was CO2 levels inside buildings, because also, around that time, people started realizing that sometimes ventilation wasn't great and CO2 levels were high. And so people were not able to really focus or started getting dizzy and things like that. So we added CO2 sensors. And then when it really boomed was during COVID, because that really shed a light on ventilation and filtration systems in buildings that were sometimes really good, sometimes really bad. People had really no idea. And through indoor quality monitoring, you're able to kind of assess that and make decisions on how improve it, how to use different mitigation techniques based on what you measure, and sometimes just save money because you're actually over ventilating and you didn't know about it.
What are some of the standards that cause a call to action, so to change something inside the building? So at what level of particulate measurement? Is that something that's left up to the end user? Do you draw in study information? Do you have recommendations? How does that work?
It's a little bit the Wild West at the moment. So
honest answer.
There are standards, like ASHRAE has a lot of standards for CO2 levels and stuff like that, mostly for making sure there's enough ventilation, but they don't really have recommended threshold to maintain. So for example, particulate matter, there's a lot of EPA standards for the outdoors, and it's been studied for a while, and the impact on health and all that stuff. Indoors, there's nothing much. So there's no real recommended levels for indoors. There's not a lot of studies on the health impacts of PM levels on health indoors, although that's where we spend most of our time. And so I think that's one of the things that COVID did, is to highlight that as well. And so now there's a lot of research, and I think a lot of working group, even within the EPA, that are trying to come up with those recommended thresholds indoors, because everybody's asking and no one has a good answer and no one wants to take a position. So what we say is monitor, try to keep it as low as you can, especially for PM. And when you detect something wrong, you can take action. But if you don't monitor, you're blind, and it's worse than anything. And so, yeah, in a lot of cases, what we see is that customers want to, on one side, they want to know, because that's the only way to be able to do something about it. And on the other side, they're like, I don't want to know, because then I have to do something about it. And so a lot of the pressure now is coming more from the public, from tenants, from parents in school and stuff like that, more than really from standards or whatever.
And I noted that you filed for a lot of patents with your business. Congratulations. What is the focus area of these? What's the novelty in those patents?
It's mostly around the applications of what we can do. Because we try to be very innovative with the technologies we use and always related to what customer will want to do. And so how do we basically prevent competition from doing the same thing? We're a small business, so we're very fast at developing stuff, but at the same time, we're not a big company with billions of dollars in R&D. So it's striking that balance between coming up with new ideas, but at the same time, protecting us from big guys from just copying us.
Sure. In the pre-call, we talked about, you'd mentioned thousands of classrooms and office spaces. In the classroom, what type of classrooms are those?
Just elementary school K to 12 classrooms. There's a lot of school districts who now are trying to improve air quality in their schools, or at least monitor it to make sure everything is okay. There is this legend that schools are really bad at indoor air quality. It's not really true. Some are, but not all of them. But with COVID, there was like a lot of ESSER fund that are basically money from the federal government to improve air quality in schools, whether it's modernizing HVAC systems, buying portable HEPA filters, doing indoor air quality monitoring. And so the most advanced thinkers out there in school districts are realizing that indoor air quality monitoring is really key. For example, Montgomery County here in Maryland deployed one IAQ sensor for each classroom they have. And so now they're collecting so much data and looking at a lot of things. And it's not just to improving HVAC system. It's really looking at a lot of things. What happens if there's construction next to a school? Does it impact air inside the school? There are wildfires coming from Canada. What's the impact? And things like that. And so they can make real-time decisions based on all that data. And then there are some states now that are trying to pass this legislation to monitor CO2, just at least CO2 in classrooms. It's not enough to just monitor CO2, but it's a good step in the right direction. So California is one of those states. We see a lot of movement there, and kids spend a lot of time in classroom. They're still developing. So there's more and more studies that are showing that they're impacted a lot by what's in the air they breathe. And as that knowledge develops, it goes also in real estate and all the other places where we spend a lot of our time.
Do you have any knowledge of or feel for the different kinds of things that may be done with the data you provide? I can think of 3 or 4 ways. One is adding additional equipment like outdoor air sources and filtration. Another might be just following maintenance procedures, cleaning, changing filters, and another might be changes in control strategy. How do those all break out, or are there any others that I missed?
When you look at the data, let's keep it simple: temperature, humidity, CO2, particulate matter, and TVOC, total volatile organic compounds. When you look at temperature and humidity, that will give you some ideas on when your HVAC system is running. And for example, you take vacant buildings during the summer or whatever, you don't know what's going on if there's no one in there. And if your temperature and humidity are not controlled, you can have mold that starts developing. That will be a hassle then after that to fix. And so based on that data, you can also see when your equipment is starting in the morning, when it's stopping, is it running over the weekend when there's nobody and stuff like that. And so you can go and act on those schedules, on those controls to adjust them, because there is like always this assumption that, okay, it's been set up one day, so it will be fine forever.
Right.
And that's not the case.
Good.
Yeah. Even like people do sometimes audit and they're like, okay, we checked that it's working how it's supposed to, or we fixed it. Now we're good. No, you need that continuous monitoring because things happen. Then when you look at the CO2 levels, that's where you will see, okay, am I ventilating properly? Is my HVAC bringing enough fresh air for the number of people that are in the room? And same thing, sometimes the rooms are designed for a certain amount of people and then there's renovation. It was some time of building, now suddenly it's for another use case. And those designs are not valid anymore. And so based on that data, you can decide, should we change? Should we bring more tight air? Should we add a fan or whatever? But then there are other things that we really had not really thought about. So one interesting use case that we've seen is that in the morning, every time the HVAC kicks on, there's a huge spike in PM. And we're like, why? And it's basically the ducts were so dirty that every morning when the HVAC kicks on, it push a lot of that dust from the ducts in the room.
The initial pressurization.
Yeah. And so it's like, I don't know, I wouldn't think about that as a problem. And so, okay, they cleaned their ducts. That problem went away. And actually, they also realized some energy savings out of that because, yeah, everything downstream was dirty and the filters needed to be changed and whatnot. And then I think another thing is also filtration. Are your filters working properly? And a big thing with COVID was like increase the type of filters you're using, but that has a lot of impact. It's going to make your HVAC work harder. It's going to consume more energy. And so sometimes it's just not necessary. And then sometimes your filters have a leak. And so it's a lot of things that people wouldn't especially think of, especially in buildings where they don't always have building engineers and whatnot. And so it highlights sometimes issues that people had no idea. And the number of applications are endless once you have that data.
We talked again in the pre-call about AI and machine learning. Quick differentiation between those two phrases?
Yeah, AI is just using computers to try to replicate human-like intelligence, and machine learning is just like a subset of AI, and machine learning is basically using data to train computers to make decisions. So it's based on data versus, let's say, a search algorithm that search different solutions and picks the best one, where it's not really trained on data, it's just based on programming, basically.
And when you mentioned that sometimes buildings don't have these building engineers, are you utilizing AI to translate and inform conditions so that people can take action?
Exactly, yeah. It's a emerging field. Machine learning has been there forever, not forever, for a long time.
Right, enough.
But it's tricky to do. But with now generative AI, it opens up new possibilities because you can use generative AI to create AI models, which is cool. And so it just makes it easier and faster to develop new tools to help people. And based on the questions they have, creating AI models that will just tell them, do this or do that based on actual data. So yeah, it's pretty cool what we can do today.
Very neat. How about you'd also mentioned energy and occupancy that must also come into the algorithm to help either make predictions or make recommendations?
It all comes together, and it used to be very siloed. And again, COVID, if you want to look at the positives of that, shed a light on the importance of the link between the different data sets. For example, you want to add ventilation in your building to make sure there's good air quality. You don't necessarily need to do that if there's nobody in the building. How do you know if there's anybody in the building? You use occupancy sensors. But then you want to quantify, okay, what's the cost of all this? What if I add 10% outside air or stuff like that? What's the impact on my cost to operate the building? Well, you need to do energy monitoring for that because most of the cost of HVAC comes from energy. And so there's a lot of interaction between all these type of data, and you can do a lot with just one type of data, but you really maximize your optimization if you have access to all the types of data. Obviously, there's a cost to collect all that type of data. Sometimes they have it. Sometimes there are buildings that have like a scanning thing with a car to enter the building. Well, that's very valuable. At least you know how many people are in the building. And so there's different ways to get the data, and sometimes people don't really think about it. But yeah, adding different sources of data, especially when you do then AI analytics, is super valuable.
And is some of the outside data literally outside data of the outdoor environment?
We do some of that outdoor data collection for more like real time and localized data. Otherwise, there's a lot more data available from the EPA and stuff like that for outdoor air, at least PM levels and whatnot. And it's its own field, which is very interesting. I went to a conference recently from UC Davis that was around mostly outdoor air. And it was amazing to me how a different field it is. It's very mature field, it seems, while indoor air is very new. It was interesting and eye-opening also how people are doing it, what we can learn from that world. But yeah, I'm still amazed how people focus so much on outdoor air maybe because of pollution and whatnot, but we don't spend too much of our time outdoors. And then indoor air, there's nothing, and that's where we spend most of our time. And sometimes indoor air can be a lot worse than outdoor air because air comes from the outside, and then we as humans also emit a lot of stuff.
There's a study that's run under a grant in the area I live in, Pittsburgh, called ROCIS, ROCIS. Have you heard of that?
No, I'm not.
Reduction of Outdoor Contaminants in Indoor Spaces. And it's a citizen science project where interested people get data monitors for all kinds of air quality and keep a diary of what's happening inside and outside, and then submit it for volunteer, mostly retired scientists to review. So I'd encourage you to look at that, rocis.org. And then back to one last point here. You talked about all the different installations that you have for your sensors. Is the modeling done? Are you able to do things that benefit from the mass of data, or is everything just done site-specific?
It used to be very site-specific. Now we're starting to do more larger scale analysis. And I think it's because of AI. It's very tedious to do data cleaning and whatnot. So every time you want to do analysis, it takes a lot of time. But now with AI, you're able to automate these things and focus on really what you want to do, not just the tedious task to get there. And so we've really seen in the last 6 months, really a huge shift. And I feel like also customers are getting more educated, or they have different questions, where before it was more like, oh, alert me if there's something wrong. Now they're asking, how are my buildings performing? Is this building better than that one? Which one are my worst building? Which ones are my best buildings? So there's a change, there's a shift in how people are thinking and what people are asking from us, which is great.
As we wrap up here, if there's any listeners, what problems or solutions can you provide? And then how should they contact you?
Yeah, we provide a very easy way to collect data from your built environment, energy, water, indoor quality. If you want to better manage your assets, basically, if you want to improve operations of your building, and we're very consultative. So we really care. We're scientists by background. So we care about the quality of the data, about the results that you get. So a lot of the sensors, we test them thoroughly, and we always talk about the quality of the sensor. If you try to go cheap, it will not go well. It doesn't have to be crazy expensive, but sometimes you want to go cheap in the way you will collect data, and it will come back later, because quality of data is really, really important. We spend a lot of time helping customers trying to figure out what type of data they need, what sensors do we need to install. And then we take them on a journey all the way to answering the questions they have about their building and whatnot. And then to contact us, just go on our website, attuneiot.com. Shoot us an email. I think there's a bunch of ways to get in touch with us. We'd love to help.
Very good. Thank you so much for coming on the podcast and giving us some perspective on this. It's certainly an honor to be speaking with someone who has so much rich experience in this area and seems like a really nice guy.
Thanks, Bill. Appreciate it.
Thank you. Take care. I'll put in the show notes the link that Julien mentioned, and also a link to his LinkedIn profile so you can learn more about his background. Thank you, Julien.
Thank you.
Thanks again for listening to this episode of the Building HVAC Science podcast. If you want to reach out and get in touch with us, you can contact us at marketing@TruTechTools.com, TruTechTools.com. The Building HVAC Science podcast is a production of TruTech Tools Limited, and full disclosure, I'm a co-owner of TruTech. And the opinions voiced are those of my guests, my co-host, or myself, depending on who is speaking, of course. And if you're in the market for any tools or test instruments mentioned in the podcast, or just in general in the fields that we cover, take a look at www.TruTechTools.com. See what we carry. And you can use the offer code HVACBS for a nice discount. We'd also appreciate it if you subscribe or give a review to our podcast. Thanks again for listening to the Building HVAC Science podcast. Until next time, take care.